Okay, so today we are going to look at distance formula, section 2.2 in your textbook. All I really want to say to you guys before we start is to keep the Pythagorean theorem in the back of your mind as we continue on this lesson. So let's take a look. Alright, so say I've got 3 points. A is 2, 3, C is 6, 3, and B is going to be 6, 6. Alright? Now I want to be able to figure out what the lengths of each line that's going to connect all 3 points together. But my main goal is that we've got to find out what AB is. Okay, we're going to figure that out shortly. So let's go first and let's look at the line from A to C. Okay, from A to C, I've noticed first of all that they have the same y value. Okay, the coordinates of A and C have the same y value, so I know it's going to be a straight line because it's going to fall only on y. So that means I've got 6 and 2. And for me to find out what the length of that is, I'm just going to subtract the two of them, right? So 6 minus 2, that's going to give me 4. So there we go. The length of A and C is 4. Then, the next thing I want to do is I'm going to find out the length of B and C. Don't worry, this gets really good. It gets better. And I can see that they have the exact same x value. So again, I know that this is going to be a vertical line, which is straight, so this is going to make my life a little easier. And to find out what it is, I'm just going to do 6 minus 3. And that is going to be 3. So I know, again, that this is 3 units, whatever the measurement is. Finally, we are now going to find out what the line from A to B is. Now, if you've noticed, something that's just kind of happened here is that I have made myself a bit of a right triangle. And right triangles are always very nice, because what comes to mind when we think of right triangles? You got it. It is the Pythagorean theorem. That's right. So let's just say, you know what? I'm going to put this in a different color here so that we can work it out and you guys can see it. If we were to do this, we would have this as C, we would maybe have this as A, and we would maybe have that as B, right? And we know Pythagorean theorem as C squared is equal to A squared plus B squared. Now, I like that, but this isn't really going to help me, especially when I have coordinates. So I'm going to think for a second. How the heck did I get A? How did I get this 4 that we now know A is equal to? Well, I did this, right? I'm going to get back into my beautiful red. If we were to have made these two, if we had made A and C points, we could have called that x1, we could have called this x2, we could call this y1, and we could call this y2 for this situation. So I could say then, to get my A, I took x2 and I minused it from x1, and then we squared it, right? Now, let me pull out my blue again, because it's what we were using earlier. To get my B value, let's just erase these, because I'm going to erase these because I just want to change up the numbers. It doesn't, change up the letters, and it doesn't really matter which ones you choose, again, as long as you're consistent. So I'm going to call these ones x1, and y1, and I'm going to call this x2 and y2. So how did I get B? Well, I just took this and we subtracted it from this. 6 subtracted by 3. So I've got 6, we try to keep it generic, y2 minus y1, and that was squared. And we got to add all that, and that is going to give me my C squared. Right? Okay. So now, the last but not least, I'm going to take that, I want to take all that and I want to square root everything, because I want to get these two to cancel. So we end up getting All right, we're going to look back right now at our old work, and we're now going to find out what the length of this is right over here. Okay, we're going to find out what the distance is of A and B. So I'm just going to remember my points, which is 2, 3, and 6, 6. So I'm just going to go to the next screen, and I'm just going to write that. We can just go back to the original right here, and if you just want to plug in Pythagorean theorem, and you want to do 4 squared plus 3 squared is equal to c squared, and you can work it out, I am 150,000% sure that you're going to get 5. And that's it. That's all that distance formula really is. You guys will be good to go from here. I wish you guys luck tonight, and if you have any questions, let me know tomorrow. Take care. C is equal to the square root of x2 minus x1 all squared plus y2 minus y1 all squared. And that's it. This is our formula. Except all we're going to do is we're going to change it, because instead of using C now, because C we use for triangles, we're going to use D, because D represents our distance. All right, D represents our distance. So let's go and let's just look back, just so that I have it. We had 2, 3, which was A, and B was 6, 6. All right. So again, what I'm just going to do is I'm just going to label them. It doesn't matter which ones you label, just stay consistent, which means that's x1, and this has to be y1. I'm staying consistent. x2 and y2, just staying consistent. So now all I'm going to do is I'm just going to plug these into my formula. So I've got D of AB is equal to everything under the square root, and you got 6 minus 2 all squared plus 6 minus 3 all squared. And now we're just going to finish it up. Equals 4 squared plus 3 squared, square root of all that. On to the next page. So this gives us 16 plus 9 all squared equal to square root of 25, and it's equal to 5. Okay, and there's my answer. So the distance is 5 units, and maybe you might have to still do this in centimeters, kilometers, millimeters, whatever the units may be. Please make sure that you write your units. And then in this case, because you weren't given anything, you can just leave it the way that it is. And that's about it. And if you want to double check that,